So there's a very scientific approach to what we're actually measuring and how we're determining this. We're not just kind of taking a shot in the dark.
Oh, wow.
And we're here today with Shannon Mutschelknaus. Shannon, how you doing?
Great. How are you guys doing?
Good. We're back in the studio, Matt. How you feeling?
I'm feeling pretty good. And we keep saying this every time. We got to keep track. But Shannon's been on probably like 4 or 5 times.
At least 4. We did a mini series of 3 before. So
it's like you and Mark Eisenstadt are up there for most frequent.
Yeah, you know, I've been slacking off. I haven't been here for a while. So
well, we'll get back on it here today.
Yeah, there was something that got people out of the office for a little while, and now that we're coming back, that's helping out. So
I was around, but you guys wouldn't come in to record it.
Fair point. But today we're going to talk about brightness and out-of-home studies and different things that we're doing to make sure our displays are serving well in the environment outside. But can you first tell us a little bit of your background? I know it's been a while since you've been on, and we have you listed as our Daktronics resident expert.
Yep.
But can you tell us what that means for what you actually do here?
Sure. Yeah, I've been with Daktronics somewhere over 20 years. Maybe the first 10 to 15 years of that, I was in design and development, designing displays, and a lot of our components that go into the displays, power supplies, and the lighting elements, the modules themselves. So I did that for a lot of years, and for the last 5 to 6, 7 years or so, I've been managing our laboratory, where we do a lot of product testing, and we basically figure out how products perform, understand their quality, their reliability, and know all about how they fail. So
awesome. And kind of tying into, like you already alluded to, Justin is talking about brightness today. So I know I always ask for things that made sense to me, so it's not talked down. I don't know what grade level we'll go, but maybe could we start out just talk a little bit about brightness and like how do we talk about when it comes to LED displays?
Right. So brightness, that's a great word. We all talk about it, right? It's on spec sheets. We see it all over the place. But a fun fact, did you know you can't even measure brightness?
What?
You can't?
It's not measurable.
Okay. Hang on, what do we measure then?
Well, we actually measure luminance.
Okay.
But stepping back to what brightness is and why you can't measure it, it's actually the human perception of the amount of light, which is different because there's a lot of parts to a human. We've got our eyes, but the thing that really throws in the challenging part of that is the brain. It does a lot of post-processing of the image, and it adds in information and interprets things that aren't actually there sometimes. And so brightness in the engineering world is an immeasurable thing. It's the human perception of the amount of light. But what we can actually measure is the luminance of the display. So there's a little bit of difference there. And I've got kind of an optical illusion here that I like because it illustrates what the brain does. That's not really there.
All right.
So this is a cool example. Give credit to Edward Adelson here. There's some papers out there that use this illustration, but we look at this checkerboard, right? You can see squares A and squares B. They're the same brightness, right?
No.
They look different to the human eye.
They look different to the human eye. They do. So, but they're different brightnesses.
Okay.
Because you see and you perceive the brightness. A and B, they're not the same. Obviously.
Yep. One's in a shadow.
Yeah, one's in a shadow. One's outside of the shadow. And you know that the square A and B are different colors. But to kind of break up that illusion, you can take that same gray, and slide that down across the two. They are actually the exact same color and the exact same luminance.
Blowing my mind.
That's crazy. So if you were to measure the luminance of that, those two squares have the same luminance.
Okay.
But they actually have different brightnesses, right? Because your brain is taking that information, that three-dimensional geometry, interpolating that shadow, and telling you that A and B are different colors.
Okay.
So that's the difference between brightness and luminance. But so you can't actually measure brightness, but the best thing that you can measure is luminance, which is the amount of light that a surface either emits or reflects.
Okay.
All right.
And our displays emit light. But you could also measure, say, the wall or this display right here.
Like reflected light?
Yep, reflected light can be measured.
Okay.
And it's the best measurement that gives you an approximation of the human perception.
Okay.
But it's not exact.
So what do we measure that in? I mean, is there
Yeah.
a unit of measure that we attribute to that?
Yep. So the units of measure for luminance, in layperson's term, we a lot of times use the word nits.
Yep.
Okay.
I see that a lot in spec sheets.
Yep.
And
Yes.
RFPs.
Yes.
Yep. And that's what most people know is the term nits.
Okay.
In the engineering world, it's preferred to say candelas per meter squared.
Okay.
Nits is just an older term for that, which actually it comes from the Latin for nitir, or to shine, or to sparkle.
Okay.
Interesting. See, we always learn something new when we talk
Yeah.
to you on this podcast.
No
This
kidding.
is great.
No, and I'm thinking too. So I'm trying to remember in our pre-call getting ready for this, you had some analogy that I remember clicked. It was the difference between luminance and nits. Do you remember what that was? You had like a really good analogy, and it made sense to me because I remember having trouble distinguishing the difference between the two. Was it like miles per hour or?
Yeah. Yeah. You
I'm
know,
not remembering that one offhand either. I was checking the notes to see if we'd written it down.
I remember saying like.
Yeah, maybe it's kind of like the difference between distance and speed.
Okay.
Where they're not the same units, but how far you travel and how fast you travel, they have a little bit different units.
Okay.
Okay, so then when it comes to these, we have the ability to control the light of an LED when it goes out. So like, how does that play into a factor with all of this? Is it what are we measuring for that then?
Yeah, so we're actually changing the amount of current, electricity going to that LED, which changes the amount of light that it puts out.
Okay.
And that, even to display an image on your display, that LED is going to be changing its luminance up and down to recreate that image that you're displaying.
So if they're talking about nits and we're saying this display has to be this many nits, say 1,000 nits,
Yeah.
we're on the back end saying, okay, we need to send this much current to these LEDs to make sure that we're hitting that nit level?
Yep, there's a lot of details in there, but usually when you're seeing on a spec sheet or somewhere, or when someone's saying the display needs to be so many nits, that they're talking about like a white image. Like if you send a full white image to that display, that's its peak or its maximum luminance that display will produce. So
Okay.
that's usually what you see on a spec sheet.
Okay.
And you really only would see that in the real world when you're looking at an image that has a white background. Like this image right here, the background is all white. So that's going to be that number of nits.
And I'm wondering if this ties into this about how you would measure it. We said like reflective of something, right? Too, and there's a phrase we hear a lot. It's called fighting the sun,
Oh,
right? So
yeah.
like if a baseball game or a football game, midday when the sun's out on it, how clear is everything versus like if it was a night game and you have to turn it down? Is it like, so would those be different luminances? Like how would you
Yeah.
measure the difference between those?
Yeah, you would want to be at a very different luminance when it's daytime or nighttime. So in the room where we're recording here, it's fairly dark because we're doing a recording studio. So what do you guys think? What's the luminance of this display?
What's like a typical range? I don't even
yeah,
know. Is it
yeah.
hundreds, thousands? Do I?
What, like
Just shoot out a number.
an average TV in your house, is that like, I've seen it on the spec sheet, that's why I threw out 1,000 earlier. Is
Yeah.
it
I'm gonna
indoor,
go-
maybe you only need like 400?
Yeah, a lot of monitors, a lot of TVs.
Okay.
That would be their maximum.
Oh my God, I was really
luminance.
just kind of throwing
I'm
something
going
out there.
532 on that one.
Are we prices right rules on this, higher or lower?
Yeah, one luminance. Yeah.
A bit of one luminance.
So this display right now is at about 150 nits.
Oh, wow.
So it like our displays, the TVs and our cell phones, they will all adjust the display's luminance based on the ambient conditions. There's a light sensor in there that will cause it to increase luminance.
Okay, so this is currently 150,
Right.
but its max could be 400, or it
Right.
could be 532.
Oh,
Right.
you remember that? That was
Right.
good.
So if we flip on the lights, its luminance is going to increase because it's going to sense that, hey, the lights are on now. I need to get a little bit brighter so that the audience can see it.
Huh.
But displays for indoor applications are going to be very limited
Okay.
in how bright or what their luminance can be. Outdoor displays will easily be in the thousands.
Okay.
Gotcha. Okay.
So I do have another image here. It kind of shows an example
All right.
outdoors of different things you can experience for nits or candelas per meter squared. So this here's just a photograph, and we took measurements of different objects within the field of view to kind of give you some perspective as to what a nit is.
Okay.
So the clear blue sky, 5,550 nits on this day.
Okay.
You know, it varies, of course,
Yep.
but that gives you a feel for what that is. This billboard here was set at maximum luminance of 3,500 nits, so fairly low for an outdoor display. And you can kind of see it looks a little bit washed out.
Yeah.
That's that sun fighting thing you were talking about. If you don't have enough luminance, you won't be able to see that.
Okay.
But the human, again, the brain comes into that, and we'll be able to compensate for a lot of things.
Okay.
And so when you're looking at a display, you really want to know what's the kind of the contrast ratio. And so it's not showing black in this image, but if the display is showing black, it's still reflecting 1,000 nits.
Okay.
Okay.
So the actual contrast ratio in this environment with this lighting is 3.5 to 1. So 3,500 to 1,000.
The white to the dark. Okay.
Yeah, so that would be the
Right.
actual contrast ratio in that situation.
So we're saying obviously different colors reflect different amounts of light depending on the application.
Well, the display isn't reflecting light, it's
Oh, right,
emitting
right. Sure.
light. But in this image, you do have other displays here, like these fixed reflective ad panels.
Sure. So I was looking, you have an electrical box and it says
Yeah.
7,000 nits, and I was like, well, that looks like a reflection of the sun on it. So that's why I said
Yep,
reflection.
Yep.
Yes.
Yep. So you can also measure the luminance of reflection.
Okay.
And that's a great example of that. So that box is reflecting 7,000 nits. This car, you're kind of right in the glare, the specular reflection there. It's reflecting 51,000 nits.
Okay.
And there's just a blank white advertisement on this this bank sign over here, and that's 13,000 nits that it's reflecting.
Okay.
So it gives you a feel for how much a nit is.
So this is a good example for what we're talking about with our displays, putting light out in an out-of-home application. This is a billboard, obviously a digital billboard. We would want to put out a certain number of nits to combat that light and make sure the display shows up correctly. And you're doing the testing on the back end to kind of tell them, here's a range that we should be aiming for?
Yeah, we will characterize what the display can produce, as well as measure at different angles, different viewing angles or vantage points, how much light is the display putting out, so that we can give accurate information to customers. If I've got somebody driving by in a car at this angle, or somebody sitting in a stadium at this position, will they be able to see the display, and will they have a good experience with that?
Okay. Because I even thought it was always just a matter of like the louvers play a part of it as well, but it's also the brightness and the angles, and not saying you just point the LEDs a certain direction, that takes care of it. But
Right.
What I think is interesting about this is even us talking about this episode was, I think our episodes with you previously, we always talked about the reliability lab. We're doing a lot of testing. We get information from the field. But something like this that you went out and did, so you actually will take things out and test them in the field even, right? Like we don't just always wait for it to, I guess, come in from customers or people out in the field,
Right.
but this is part of what you guys do too.
Yeah, yep. We can help people with measurements in any kind of situation, as well as help people know how to use the information and the data and the measurements.
Sure.
That's probably one of the hardest things because, sure, this displays 5,000, 6,000, 7,000 nits, but what does that mean? How do you take that and make use of that in the real world?
So you're helping them apply it correctly. And it's not just, like you said, okay, you can see it really good at this angle, or you can see it here when you're driving by, but it might also to be limiting light in directions you don't want light to go. Is that correct?
Right. That's a very big concern. And first of all, you don't want to waste energy. Well, when you don't want it to be brighter than it needs to be visible to the audience. But there's times of the day, not during daylight, but at the nighttime, where you really don't want to be having negative effects on the people or the residents maybe that live near the display or anything like that. And so we have that kind of information and that data and can help people make decisions for their application.
I say we have a lot of different displays that we use in a lot of different applications, right? Like,
Yeah.
So is a billboard scenario kind of like the one you're showing us here? Is that kind of the best one for you to do some of this testing on? Like, I know I'm not saying it doesn't matter in stadiums or arenas, but is this kind of like what you look at to test when you look for an environment to do it with?
You know, a lot of times, or, you know, we're usually looking at stuff like in cities that's probably operating at night. So a stadium arena is just kind of operating, you know, during the show time where the event's happening. And people are pretty used to bright lights because you've got all the stadium lighting, you're watching something happening out on the field. But in an advertising billboard type situation, you may be having a dark environment around it, or you might have people that are trying to sleep in apartment buildings next door, and you want to make sure that they can sleep well at night.
Yeah, and I'm thinking even further, like, who else cares about this information? It's not just us as the seller or creator of the technology or the purchaser, but they've probably got to follow those regulations if they're in those certain areas. So are there other groups that really need to know this information as well?
Yeah, you know, if you're setting those regulations and standards, knowing this information and how to use this information is really important. So I have an example I could show where we've done that. This here is in Australia. You guys been to Australia?
I have
No.
not.
I haven't either. I've only been there in Google Earth, but this was for some folks in Australia, so we wanted to pick a local site that they're familiar with.
Okay.
So this is the intersection of Flinders and Swanson in Melbourne, Australia. And there is a sign right on the side of this building here. You kind of see where that sign is.
Oh yeah, the blue arrow. Yep, got it.
Yep, by the blue arrow. So this is just a nice case study that we did to show how to use the information, the data. So here's a display. We want to make sure that the intended audience can see that display and read it at night. In this example, you can see this is a top-down view, and the green highlighted area is where we would expect the audience to be. So it's people driving by on the road or people in the concert area here where they're having events and getting together, being able to see this display. So this is all kind of looking at nighttime. So how bright, what's the luminance of this display need to be visible? So there's a lot of great guidelines out there for that. Okay. So we took this research paper has got this big equation. Maybe you guys could walk me through this?
It looks like a graph, and there's a bunch of numbers.
Is that algebra?
It does look like it.
Oh, yeah, there is algebra included here, guys. Sorry about that.
L equals something. Yeah.
But the key point is there's a few inputs that you want to know. So you take into account what's the visual acuity of the traffic of the person, you know. So we assumed a 20/40 vision. You're maybe familiar with like 20/20.
Yep.
As you age, that visual acuity goes down, and you want all people of all ages to be able to read the sign. And so actually the visual acuity, the age of the driver, the distance that they are from the display goes into that, as well as the size of the characters that they're putting on the display. So, a bigger letter is going to be more visible. So we looked at what they're actually displaying on this image. And this is an image from Google Earth, outside of the viewing angle, but just so you can kind of see what is the size of the characters that they want to display. And this is a Harry Potter show that's going on. And so you can take the character size, all those things into account. Then you can estimate what the luminance should be to make that visible. So at nighttime, under these conditions, the luminance for different character sizes is shown there, between 40 nits to 125 nits.
Okay. So the brightness comes into effect with the readability of the letters and everything you put on the display too.
Right.
And I'm thinking to start this whole thing off, so aside from you just maybe wandering around Google Earth, but what kind of prompted you to do this? This was something a customer was asking for, or kind of what started this even the research to go into this project.
We were helping a standards committee set some good guidelines for what amount of ambient stray light could fall onto adjacent properties. So usually it's in a national industry, or sometimes there's city guidelines, but usually we're working with national agencies like, okay, well, how do we set good guidelines for our communities that allow the displays to be visible? Because sometimes they're displaying mission critical things like important traffic alerts and all that stuff. And it can be a safety hazard if people can't read the sign.
Sure.
But you don't want it to be blasting light out, keeping people up at night or affecting, the neighbors.
Yeah.
Right? So you need to have a balance there. And so this is some of the work we're doing to help them establish some good guidelines.
Okay. And I like this because it's a combination of, it's not just, I mean, we're talking about brightness, but when we start getting into the size of the characters, so it's not only just about being able to see it on or off, it's also being sure that it's
Legible?
legible.
Yep.
I was going to wonder what the word was. Yeah, so it's legible for people going by, which obviously then helps advertisers and everyone else. So you're not either making the text too small that no one can read it. So you're trying to get it about that sweet spot in the middle.
Yeah, yep. Yeah, in this case, we're trying to give some guidelines. Well, how bright should the displays be at the maximum brightness in this nighttime scenario? The other thing that the data that we produce helps people select different products, because we have different products that put out different amounts of light at different angles. Unlike a lot of traditional technologies like a static billboard that has a light shining on it and it's reflecting off, you can't really control how that light is reflecting off, and so you have to have a lot of stray spill light. But with LED signage, it can focus that light towards a particular vantage point or a particular viewing area and really eliminate that stray light.
Okay. And Matt was saying you weren't just kind of looking around Google Earth and decided, hey, let's go to Australia. You were doing that to help their standards committee. They were doing a special project. Is that just kind of one of many, or how long have we been kind of honing in on where this light's going to go to make sure we're not wasting energy and limiting that ambient light into other areas?
Yeah. I mean, we've been doing it for years, but there's really a lot of different applications. Sometimes it's maybe a downtown metropolitan area and there's some residences up on the hill, right? And we want to make sure that there isn't any obtrusive light shining into that area. So then we want to take our product data and make sure that the right product's being selected. So
it might even
you guys like graphs, right?
Oh, yes.
Of course.
All right. Here's a slide with some more graphs that are curvy and hard to read probably. But this is an example of just the differences between two different types of technologies or products that are pretty common in the LED display industry. So on the top, we have a wide view display.
Okay.
And this here polar circular plot, that the shape of that curve is showing how much light is going out in different directions.
Okay.
And maybe folks don't use these graphs all that much anymore. Most of the time, people will actually ask us for the three-dimensional file that has that data in it at all different angles.
Okay.
And then they can put that into light simulation software and simulate, okay, on this building here, there's going to be this amount of light and there. So the main difference here is between this wide view and this focused view, that red curve there. You can see one, it's wider, and one, it's narrower.
Sure.
And it's focusing the light more directly forward.
So with this whole technology here of testing, you can look and help somebody decide what technology would be right to limit the ambient light for their specific application. Once you know, okay, a display is going here, they want to target these viewing angles, but not bother the people over here. You can take all that into consideration and start looking into things?
Yep. We're producing the product data so that engineers, wherever they are in the world, can look at, okay, this display here, is it going to be the right one for my application? So so how do you take this data and you use it? Mm-hmm. So here's after that data is actually like plugged into a software tool.
Okay.
So this here again is the same intersection in Melbourne, where we have the sign. Kind of see that white square beside. Yeah. That's the sign.
Okay.
And then these other blocks are the buildings around that sign. Okay. And we didn't talk about illuminance, which is different than luminance.
Okay.
But it's the measure of light falling onto a surface.
Okay.
And that's really what you want to know when you're like, oh, how much light's falling on my window? Like I can't sleep at night. How much light is hitting that? That's measured in lux or foot candles, if you're in the United States, foot candles. But lux is more common around the world.
Just so I understand that, illuminance is what it falls onto. Luminance is what it's coming at you. Is that more?
Yep. It's what you see and perceive with your eye is luminance.
Okay.
What's falling onto a surface would be illuminance.
Okay.
Oh, okay. So because luminance means that like it could be reflecting back on you, and that's what you're seeing.
Yes.
But reflection has nothing to do with illuminance. It's just the amount that hits it.
Yeah,
and then nothing afterwards.
Yep.
Is it?
Yep. Like you could have
Illuminance,
a black surface, right? It's not going to reflect as much, so it's going to have low luminance, but it's still going to be illuminated to the same amount.
Okay. Got it.
Got it. Okay.
Makes sense now. Yeah, sometimes we have to break it down so if we can understand it, everybody else can probably
That's usually
understand
the
it.
way,
The words they're really hard because they're almost spelled and pronounced the same. So it's like, what's the difference? I don't know. So here you can see on these different buildings. Of course, the farther away, you can see there's less light on it. Depending on what angle it is, there's different light on it. So, for example, this orange-looking building here, there's an average of 1.3 lux falling onto it with this wide view LED display. Okay. So if you do that same analysis with the narrowed viewed one, we have less light falling onto that building, 0.9 lux.
So it's safe to say there's a much more scientific process going on here than just us looking at it and saying, it looks like there's a lot of light falling on that building. We should probably see what we can do there.
It looks pretty bright.
There's a lot of data and details and measurements and large words that can get complicated going into this. So there's a very scientific approach to what we're actually measuring and how we're determining this. We're not just kind of taking a shot in the dark.
Oh, wow.
Sorry. I realized it as I was saying it. I apologize.
And then I'm not sure if you'll get into this then, but my mind is immediately thinking of how are we doing this, right? I mean, it's not, I don't think it is as easy as just turning LEDs to face a certain direction or go less LEDs. Like, how is there a way to actually affect the amount of lux or nits the display puts off?
Yeah, there's a lot of ways to affect the amount of light it puts off, like straightforward, and a lot of ways to control that in different ways, side to side. So all of these product characteristics, they have like a straightforward measurement, and then they also have at different vantage points that data too. So we have a variety of things. Different LEDs have different emission patterns as to how they spread the light, and so we'll select different LEDs and have a range of products available for customers to do that. Then there's also techniques. I'm not sure I can talk to you about all of them. There's also ways to prevent that light from going at particular angles.
Okay, so you've talked about certain standards committees that might need to know this information, certain governing bodies that might put limits on certain amount of illuminance on certain areas, and you've talked about how you can help that for a specific project or a certain technology, and how we can control certain things. Is there anything we're kind of missing with the brightness that we can test for our displays for different applications, or have we kind of rounded the bases on all the different things here today so
I thought
far?
we were going to give another light analogy there.
No, I'm done with dad jokes for today.
Dad jokes, yeah.
Well, there's really a lot more you could delve into because there's a lot more than just the amount of light it puts out. There's also the quality of that light it puts out. So what's the color of the light? That can change by different angles, and there's a lot of those details, but we'll save that for another podcast.
Okay, just making sure we've covered everything we needed to today to get the basics of this brightness and kind of the studies that we've done and how we're working with customers and with our technology to ensure that it's working well for everyone involved.
Yep.
And so, but we won an award for this, right? I mean, you wrote up a release for it.
Yep, it was in Australia based on this study. I believe we won an award for the work we did on that study.
Which is this.
Yeah,
study, right?
The Outdoor Media Association awarded us for the help and assistance we provided them in setting these guidelines and giving them the technical information and expertise to make these engineering-based decisions.
Yeah, definitely some scientific approach going on there that we learned a lot about today already. So thank you for coming on and sharing all of that and walking us through this study. It was very interesting to hear about.
Yeah, you're welcome, guys.
Thanks, Shannon.